You've built an incredible AI workflow. It feels like absolute magic initially. But then you hit a very frustrating wall. You still have to manually press enter. You do this every single time it runs.
Yeah.
You've built a sleek digital Ferrari, but you're kind of just pushing it down the street. You are still the ultimate bottleneck.
It really kills the magic, doesn't it? A workflow just isn't a true system yet.
Welcome to this deep dive. Today, we're exploring a really fascinating source guide for you. We are talking about deploying Claude automations effectively.
It's a great topic.
We're going to cover an entire deployment spectrum today. We'll start with simple local tests using Claude code. Then we'll move into fully autonomous cloud agents. These are systems running quietly in the background, 24/7.
It's a beautifully logical progression, I think. We'll break down the Watt framework first. Then we'll explore those simple local loops. After that, we examine scheduled cloud routines. Finally, we look at the massive back-end powerhouses, platforms like Modal and Trigger.dev.
Before we figure out how to deploy something, we need context. We must define what we are actually deploying.
That is exactly where you have to start. You must answer two fundamental questions first. You need to define the location and the autonomy. Location simply asks where this code will run. Will it live on your personal computer or a server?
Right.
Autonomy asks how much freedom Claude actually possesses.
I saw this acronym in the source guide, WAT, W-A-T. I completely understand the workflow and the tools, but where does the agent piece actually fit in?
It's a really great mental model for developers. The workflow represents the rigidly defined steps. It is the clear path Claude must follow. The tools are the extra software features. They connect Claude to external programs securely. The agent is the active thinking brain. It analyzes real, unpredictable situations dynamically.
A deterministic workflow is like a factory assembly line. It is highly efficient and perfectly predictable.
Yeah.
But if a part arrives upside down, the line jams. An agentic setup is totally different. It is like putting a human floor manager on that line.
Ooh, I like that.
They can look at the upside down part, they realize it's a mistake immediately, they flip it over and keep things moving.
I absolutely love that analogy. It perfectly captures the mechanical difference.
But I want to push back on this a little. Don't give Claude broad decision-making freedom if a fixed script works. If the task is simple, keep it entirely restricted.
Oh, I completely agree. Matching the autonomy level to the task is crucial. It prevents massive, unnecessary over-engineering. Plus, it stops you from burning through expensive API costs. Deterministic methods offer perfect, unwavering consistency. You want that exactness for repetitive daily tasks.
Right.
Agentic setups are reserved for completely unexpected problems. They handle entirely new, unstructured data gracefully.
You have to build the right machine for the job. A simple data transfer does not need an advanced brain. Beat. So, how do we define the agent part of WAT precisely?
A setup becomes truly agentic when it reviews live data. It has to choose the next action itself. If it decides which tool to use, it is an agent.
So an agent independently chooses its next practical step.
Yeah, that's exactly it. Let's move to the simplest deployment method available. We'll start with local automation loops.
Yeah.
This is your trusty train on tracks. It happens right on your own laptop.
You just use the Claude code loop command. You literally type it in plain English.
It is shockingly fast to set up, You ask Claude Code to repeat a specific job. Claude creates scheduled cron tasks automatically behind the scenes. You might tell it to loop every 10 minutes. It can check the latest Bitcoin price action. Then it saves a summary into a markdown file.
It translates that natural language into a schedule instantly. It runs the very first check right away. But the guide mentions two very different environments here, the desktop app and the terminal. Why does the environment matter so much?
Because they behave very differently under the hood. The desktop app provides beautifully stable cloud sessions. It handles complex environment variables automatically for you. But there's a massive catch to remember. If you clear your chat context in the app, it dies. Your loop stops permanently. The memory is tied to that specific window.
The terminal environment gives you total command line control.
Right, and that makes the terminal much more robust. Wiping your session in the terminal is structurally different. Your scheduled tasks actually survive a cleared screen. They keep running safely in the background shell.
Okay, that makes sense.
But every local loop faces three crucial structural limits. The first is called time jitter. Cloud infrastructure shifts exact start times naturally. It prevents severe server overload from simultaneous requests. A scheduled task might trigger up to 30 minutes late.
So you cannot rely on it for exact timing.
Never. There's also a hard expiration limit. Loops die completely after 3 days on the desktop app. Will last exactly 7 days in the terminal. You have to go in and restart them manually.
And then there are the notorious context limits. I have to admit something here. I still wrestle with context limits filling up my memory window. It degrades the AI performance so drastically.
2-sec silence. Trust me, it happens to absolutely everyone. Continuous operations consume your available memory window constantly. It fills up extremely fast if you aren't careful. The solution is actually quite an elegant workaround. You just ask Claude to run a concurrent clear loop. It wipes the slate clean periodically to save memory.
That is a very clever engineering workaround. It keeps the local system fresh and responsive. Beat. But how do we manage that 30-minute time jitter practically?
You simply avoid using local loops for strict time-sensitive tasks. Use them for frequent checking, like reading YouTube comments, where exact timing really doesn't matter.
I see. We keep local loops away from strict, inflexible schedules.
Precisely. Which brings us to the next logical deployment problem. Local loops are a fantastic starting point, but there is an obvious physical ceiling here. Eventually, you are going to close your laptop. We need to move off the local machine entirely.
We move up to scheduled tasks and cloud routines.
You can actually use local operating system schedulers first. Mac users employ a hidden tool called Launched. Windows users rely on the classic task scheduler. This guarantees exact execution times down to the minute. You maintain complete, secure local control over the scripts.
But your personal machine must stay awake constantly for that. That feels like a major impractical limitation. Native cloud routines solve this problem beautifully. They live natively inside the Claude web interface. They run securely on remote, dedicated cloud servers.
Yeah, it frees you from the hardware entirely. Your tasks continue running long after your PC shuts down. The setup process is remarkably accessible for anyone. You enter a simple name, like Daily Code Review. You write plain execution instructions in natural language. Then you set a schedule, like weekdays at 9 a.m.
The source guide mentions using connectors for secure authentication. You can ask Claude to check a private Gmail inbox. It reads incoming messages and drafts contextual replies automatically. Claude handles the entire complex authentication process natively.
It guarantees a remarkably smooth, hands-off operation. But there's an interesting mechanical detail about cloud scheduling. Cloud servers almost always add a random execution delay. They deliberately shift fixed times by several minutes.
Just pause and think about that for a second. We take it for granted every single day. But whoa, imagine the cloud infrastructure managing millions of these delayed triggers. It balances planetary computing loads to maintain peak performance. 2-sec silence. The scale of that invisible coordination is staggering.
It truly is a massive invisible planetary computer. It ensures the whole global system runs smoothly. But as a developer, you must know the limits. Cloud servers enforce strict maximum runtime caps. They ensure fair resource distribution across all concurrent users.
Complex scripts require massive amounts of data processing. They might time out prematurely before finishing. What is the real risk with these maximum runtime caps?
If your connected external APIs respond slowly, your script just burns time. It hits the cap and terminates completely before finishing the actual job.
Slow external API responses essentially bankrupt your allowed time limit.
Spot on. It is a vital architectural constraint to remember. Sponsor found.
So we've solved the basic infrastructure problem. The code runs 24/7 on cloud servers. We've covered local loops and native cloud routines. They are very accessible and easy to start. But there is another ceiling we hit eventually. What if your workflow needs to connect directly with secure databases?
Or what if it needs to monitor a team's code deployment? Cloud routines simply cannot handle that heavy lifting alone. You need to leverage independent external platforms. They provide highly flexible, massive resource expansion capabilities.
The source highlights two major heavyweights in this space, Modal and Trigger.dev. Let's unpack Modal first to understand the mechanics. It is heavily Python-based and built for engineers. It offers an incredibly powerful serverless architecture.
Serverless architecture is the absolute game changer here.
Meaning code that uses computing power exactly when it is running.
That is a perfect, concise definition. Think of Modal's serverless setup like a ghost kitchen. You aren't paying monthly rent for a 24/7 space.
Right.
The moment a request comes in, Modal instantly spins up a kitchen. It cooks the data, serves it to Claude, and demolishes the kitchen. It immediately stops the billing clock.
Modal processes heavy Python workflows with incredible efficiency. It has a remarkably low cold startup delay. It packages all the complex source code dependencies automatically. It assigns dedicated memory resources right at activation.
It is perfect for secure, direct database access. Modal spins up powerful direct query scripts instantly. It safely authenticates identities on platforms like Supabase. It pushes that raw data directly to Claude Code.
It optimizes those backend resources very aggressively. A specific command automatically closes the active connection stream immediately. It happens right after receiving the final analysis results. This maintains excellent system performance and saves money.
They use a central fast API endpoint for management. It routes all incoming traffic smoothly and logically. This maximizes your free server capacity intelligently. You can run continuous cryptocurrency news streams very efficiently.
Modal is clearly a robust, enterprise-grade solution. Trigger.dev serves a slightly different, highly specific purpose. It manages extremely long-running background tasks safely. It coordinates smoothly with multiple external APIs simultaneously.
Trigger.dev provides a beautiful visual control panel. It builds a seamless, highly observable automatic operation sequence. Developers use the local command line to start their projects. Then they deploy to the cloud extremely quickly.
It is perfectly designed for external event listening. Let's walk through a practical pipeline step by step. The server records an update signal from a GitHub repository. Trigger.dev intercepts that signal instantly.
All right, and it calls the system and requests Claude code. It asks it to analyze the source code. This happens right after the project finishes deploying on Vercel. The transparent visual dashboard is a massive advantage here. Managers track the exact, real-time progress of independent tasks. They meticulously save the entire error log for debugging.
But this immense back-end computing power comes with a cost. Every single data analysis loop consumes developer account credits. External systems always enforce strict API call limits. Financial control becomes absolutely critical at this scale. How do we avoid surprise API bills with these platforms?
You must proactively set strict resource runtime limits on the platform itself. You also need automatic spending alert thresholds installed immediately before running anything.
Got it. You always enforce hard runtime limits and budget alerts.
Yes. Otherwise, a silent looping error will quietly drain your account. Let's pivot to the final, most advanced layer. We've established robust scheduling and solid infrastructure. The code runs automatically without breaking a sweat. But what happens when the incoming data isn't formatted perfectly?
What if the system encounters a scenario we didn't explicitly code for? A rigid script just breaks in that situation. We need to give the system a true dynamic brain.
Exactly. A cloud automation might still need Claude to review completely novel data. It must use specific tools dynamically based on context. It has to independently choose the next logical action.
That requires implementing the Claude Agent software development kit. You use the SDK for workflows requiring highly flexible decisions. The source gives a really fantastic, practical example. Imagine a brand new lead qualification agent.
Yeah, let's look at the mechanics of that. The agent reads a totally novel customer inquiry. It isn't just parsing formatted database fields. It judges the priority level completely independently based on language. Then it suggests a customized follow-up action. It is not just following a rigid script anymore.
It is actively reasoning about the unstructured information. For ongoing work across multiple runs, it needs memory. You store a unique session ID in your database. You send that ID back to continue the exact same context. It perfectly remembers the previous interactions and decisions.
The SDK handles that complex agent-style execution beautifully. But the source also mentions a fascinating hidden power feature. They call these reactive mechanisms hooks.
Hooks let Claude code perform an action after a specific event. It acts like a hidden reactive tripwire in the code.
They don't interfere with the main agent logic at all. For instance, right after Claude successfully uses a tool, a hook triggers, or after it updates a critical file or finishes a complex task, you use hooks to send instant Slack notifications.
Or you can use them to quietly check outputs before the workflow ends. It adds tremendous visibility to the entire process. You get vastly better control without creating another complicated schedule.
The decision matrix for all of this is highly practical. You must always start with the simplest approach. Ask yourself, does the task even need Claude's brain? Simple sync jobs just need a basic dumb script.
Does Claude actually need to make independent decisions? If yes, then you use Claude Code or the Agent SDK. Must the task run reliably when your computer is powered off? Choose a native cloud option.
And will another external system trigger the task dynamically? If it relies on external webhooks, Modal or Trigger.dev fits best, always start with a repeated task that produces an easy-to-check result.
Confirm that the basic logic works reliably first. Then expand the system gracefully into the cloud. Beat. What is the most practical use case for these hidden hooks?
Hooks are absolutely perfect for recording system logs silently in the background. They monitor the agent's actions without cluttering up the main workflow logic.
So hooks silently track system actions without complicating the main workflow.
Exactly. They are an incredibly elegant and highly efficient solution.
This entire technical progression is incredibly revealing. Deployment is truly the structural bridge. It connects a neat little AI trick to a reliable working system.
Mm-hmm.
You test the logic locally with the simple loop command. You schedule it with Cloud Routines for closed laptop reliability. You scale up to Modal or Trigger.dev for massive back-end power. Finally, you inject the agent SDK when the system actually needs to think.
It is a wonderfully clear, highly actionable roadmap. You finally stop being the manual bottleneck forever.
You hand the repetitive execution over entirely to the machine, which leaves us with a truly massive philosophical question. If setting up these autonomous routines becomes this accessible and easy, what happens to our traditional 9-to-5 workday? Just imagine a world where hundreds of invisible customized microagents are quietly handling our digital lives in the background. What exactly will we do with all that reclaimed human time?
It represents a profound shift in how we fundamentally define work.
It absolutely is. Thank you for joining us on this deep dive. Keep questioning the systems, keep building thoughtfully, and stay curious. Out to your own music.